let's take a look at the component of GIS. Okay, number one is the hardware. We have two examples of hardware, computer and peripherals. Okay, for computer, as I mentioned earlier, used to do the analysis to process the data. Okay, so the computer must be fast and accurate. Okay, we also need to consider maximum memory storage for the RAM, the storage and backup storage. Okay, we also need to make sure that the computer have a large monitor and large graphics card, because we are dealing with a big amount of visual. Okay, and then for peripheral, okay, peripheral refers to the pieces of equipment that support the computer and the GIS and allow a variety of input, output and storage options. Okay, example is for input, handheld GPS, okay, can be used to collect the information. Okay, it's a two-in-one where we can actually collect the data, locational information, and also you can map the field objects. Or another example for input is keyboard, mouse. Okay, and then for output, the most obvious output device is the printer. Okay, the high quality printer is in its ability to provide a high quality interpretive map. Okay, the main specification that a user should be aware of when looking printer is DPI, okay, which is dots per inch. Okay, the last peripheral is storage. Storage is very important not only for daily use and accessibility, but also for sharing data and for backing up important data. So the sharing of the data can use two methods, which is networks, allow sharing data within local areas, providing wider accessibility and for backing up data, and also number two is USB devices. Okay, for example, memory sticks, secure digital cards, or compact flash disks. Okay, component number two, data, which is refers to the digital maps, underlying list of attributes and values, and the image of the area study. Okay, so the data can comes from different sources and formats, spatial and non-spatial data. Okay, the data can be maps, it can be image, it can be digital products, GPS data, text data, or tabular data. Okay, so in GIS, we can also use paper maps for analysis. Okay, but then this paper map needs to be converted into a digital map first before we can proceed with the analysis. So there are two ways of doing this. Okay, which is converting the paper maps into a digital map or electronic map. Okay, number one is by using a digitizing table, and number two is georeference. Okay, method number one, digitizing map using a digitizing table. Okay, you have to place, or you have to put your map, the paper map, onto a specialized table. Okay, and then we have a special mouse like puck used to trace the boundaries of the objects from paper map to create a digital copy. Okay, so this paper map is then scanned to create a digital image of the map before it can be used within the GIS system. Okay, and then the second method, if you have aerial photo, okay, the aerial photo is not digital, meaning that the photo does not have location info, so we can convert it into a digital form or electronic by using a georeference method. Okay, so to digitize an aerial photo, we need to place the coordinates of certain objects in the photo, okay, so that the system will actually calculate the coordinates of each pixel automatically, okay, when you use the georeference tools in the GIS system. Okay, you need to have a minimum 4 points of locational info for the georeference. Okay, once you are done with the georeferencing, each pixel in the aerial photo will have its own locational info, meaning that each pixel will have their own coordinates. Okay, once the aerial photo has the coordinate info, then it was digitized. Okay, component number 4, personal or person or people who handle the GIS. Okay, it can be a specialist or a network administrator, or any people who can conduct the to do the analysis in GIS system. Okay, and then the last component is software. Okay, which is consists of two components: database component and map component. Okay, for map component, this will allow user to view representation of spatial objects or to visualize the results of converting data to information. Okay, uh, uh, so you have to know in GIS, okay, the basic principle of GIS. Okay, we are working with layers. Okay, one data to one layers. Okay, so it is the compilation of layers lah. Okay, so the map layers are not just confined to spatial objects, for example trees, houses. Okay, a special event can also be mapped, for example rainfall, earthquake, floods. Okay, and then for the database component, DBMS, okay, as simple as Excel having row and column to display the data. So each column is an attribute of the map's layers object data value entered for each individual feature in the intersecting cell.